Okay, so welcome back. And so today we're going to now start our next section, which is going to be on zeros of polynomial functions. Okay, and so the first thing we're going to talk about is what we call the factor theorem. So the factor theorem has to deal with, well, you would guess it, factoring polynomials. Okay, now not just quadratics, but any kind of polynomial function. Okay. So in this case here, I'm going to start with, consider the polynomial function f of x equal to x squared plus x minus 2. And consider also in its factored form, so which is written here in its factored form of x minus 1 and x plus 2. Okay, so then notice that f of 1 is equal to 0, obviously, and f of negative 2 is equal to 0. So you notice that it looks like there's a special relationship between the values of the function and their linear factors, right? So it looks like we're going to be able to use synthetic division, right? So remember we talked about, hey, this is a 0, right? 1 is a 0 of this polynomial function. Negative 2 is also a 0 of this polynomial function because we can show by using the remainder theorem that this is equal to 0, right? So, but again, we're just using factoring, right? So this is a very simple example just to show you the relationship between being factored and having a 0, right? So that leads us to the factor theorem. The factor theorem says that for any polynomial function f of x, x minus k is a factor if and only if f of k is equal to 0. So let me say that again. For any polynomial function, x minus k is a linear factor of the function if and only if f of k is equal to 0. Well, how are we going to determine if k is equal to 0? F of k is equal to 0 by using the remainder theorem and using synthetic division. So now and this is an if and only if, which means goes both ways. So if I can show that given a k value that f of k is equal to 0, then x minus k has to be a factor. Likewise, if x minus k is a factor, then I know that f of k has to equal 0 as well. Okay? And so we're going to do an example to show how we can use the factor theorem to help us factor polynomials. And not just polynomials of degree 2, but factor polynomials of any degree. But we'll get there. Okay.